Hey, what's up, everyone? I want to introduce this new project I'm starting, and it's going to be called Project Ester. And my goal in this project is to teach chemistry. But I want to start a bit more generally and talk about why we should study chemistry in the first place. So, you've definitely seen pictures of nebulas, and I want to introduce this really cool one that are one of my favorites. It's called the Pillars of Creation. And you can kind of see why. There are these like finger-like protrusions coming out of this base area, and sometimes we forget about how big these nebulas are. So that little finger bit at the top, or what looks like a finger at the top, is actually bigger than our entire solar system. And at the base of it, that entire thing is bigger than 2 light years. So really, nebulas are massive, and we sometimes don't think about how massive these nebulas are. We think maybe they're about the size of our solar system or so, but no, these nebulas are freaking massive. And so I think this is one of the coolest pictures that we've ever generated. And the reason I say generated is because if you were to actually be there and look at this nebula, this is really not what you would see. What you would see is infrared. And of course, you can't see infrared, so really you'd see nothing. But this is a picture we took with the infrared camera. And so you can see how these are actually infrared light. But I don't think this picture is nearly as cool as the first one I showed. And so how did we really get the first one? Well, we colorized them based on what elements there are. So the green bits represent hydrogen, the red bits represent sulfur, and the blue bits represent oxygen. And it's kind of cool how these molecules have no intelligence. Like, these molecules don't know that they're shaped like, a hand or these pillars. These molecules are just playing by the rule book of that is chemistry, right? But when we colorize them this way and we look at them this way, they look like these hands or these pillars, and this is not unique, right? You've definitely seen other nebulas, and these are some of the other ones, like the giant squid nebula that looks like a big squid, or like I'm realizing now that it also looks kind of like a knife. We also have the ant nebula that looks like an ant or like some like weird spider. We also have something like the butterfly nebula, which I think is like one of the coolest of them all. It's this like beautiful butterfly-looking shape. But really, the molecules themselves don't know that they're shaped this way. Chemistry, which I like to think of chemistry as like the rule book for how molecules and atoms interact with each other, chemistry has made them this way. And so understanding why some things are like this way is at the fundamental roots of everything in the universe. Everything in the universe has roots in chemistry. So if you can understand chemistry, you become a lot more powerful as a person and a lot more knowledgeable in general. But chemistry has this infamy for being hard and really complex. And to demonstrate this, I want to look at this chemical equation. And you'll notice that you'll notice pretty soon that I suck with nomenclature, which is, like the naming of molecules. So I'm not even going to try to pronounce this, like the molecules in this reaction. But essentially, it's this really massive, complex reaction, right? If you were taking like a chemistry class and your teacher put this on the test or something, you would be pretty mad at them. You'd be pretty pissed. Because I don't think anyone expects you to memorize this equation. Yet this equation is one of the steps of glycolysis. And glycolysis is how your body turns glucose into usable energy. So really, without this single reaction, you would be dead. And this single reaction is happening trillions of times a second, right? It's happening in every person's body all the time. So it's sometimes it's sometimes easy to lose perspective, right? If you look at this weird chemical equation that you see in class or in like a YouTube video, and you think, when am I ever going to use this? Well, really, you're never going to use it. You yourself are never going to use it or noticeably use it. But the universe is going to use it a lot. This single reaction is happening trillions of times a second, and that's only in our planet, right? We don't know if we have aliens, or we don't know if other people all over the universe are using this equation. But something like, like the breaking down of helium into energy or whatnot, like nuclear chemistry, that's happening trillions and quadrillions and nearly infinite times a second. So, that infamous question, when am I ever going to use this? Well, you yourself are never going to use it. But you have to remember that it's being used all the time. And so if you understand not only how they work, but why they work, then you yourself do become a lot more powerful. So there's this intricacy, there's this complexity to chemistry, but within it is usefulness, and within it there's beauty in there. And so sometimes it's really hard to learn something unless you have a clear goal in mind. And one of the things that is out there for, I guess, US people living in the US is something called the USNCO. And the USNCO is the United States National Chemistry Olympiad, and it has these four stages, I guess. First up is the local exam. And the local exam is a test that you take in school. You can sign up to take it. And in every school, they pick two people to represent them in the national test. And the national test is just like the local test, except it's like a bit harder. And the top 20 people on the national test get to go to something called study camp. And at study camp, they help develop your chemistry skills. They teach you more complex things. And only a couple of people in study camp get chosen to represent the United States in the International Chemistry Olympiad. And so the United States Chemistry Olympiad is like the best of the best, if you will. But you know, teaching people how to get to the International Chemistry Olympiad is not my goal. And it is also not the goal of the people who make the test for like the local test and the national test. The goal for those people is the same goal as mine. And you can really see their goal if you look at some of the questions that they put sometimes on the test. And I like question 64 in specific. As a result of my participation in the USNCO program, I have a more positive view of chemistry than I did before participating. What they really want is for young people to get more into chemistry. And that is exactly what I want. Right? A lot of people look at chemistry and they really don't like it because they think it's these like weird laws and these weird rules that have no correlation to one another, that they don't think that they're connected or there's any use for them. But that's not true. As you just saw, chemistry has uses all over the universe. And so if you understand chemistry and you have a good positive view of chemistry, then you become better as a person. Or at least I think you become better as a person. So my goal here is to help you get out of chemistry with a more positive view of it. And the way I'm going to do that is by teaching you the units in the USNCO. So what I'm going to do is I'm going to focus on questions on the local and national test and teach you the units there. And by the way, these are the units. So they go from stoichiometry to lab to states of matter, thermodynamics, kinetics, equilibrium, oxidation reduction, atomic structure, bonding / molecular structure, and then organic chemistry. And I want to go over all these units. And really the reason why I'm doing this is because when I was studying for this test, I looked online and there was basically nothing that was free to help people learn. So when you have like a clear goal in mind, it's also helpful to have some resources. Because without resources, things become a lot harder. And when things are harder, you're less likely to do them. So I really want people to get into chemistry, but I can see why it's kind of hard if you don't have the right resources to do so. And so I'm going to go through all these units, and hopefully by the end of this, you have a better understanding and a more positive view of chemistry. So I don't think a lot of people will see this, but if I've inspired at least one person to, learn chemistry and join me on this, I guess, journey per se, then I'll be happy. And so that's all I have. I hope to see you in the first unit, which is going to be stoichiometry. So I'll see you later. Thank you.